Okay, nuclear fission. Right, first thing about nuclear fission, it's got double S in the middle. This you must spell this correctly because there's something called nuclear fusion, and the examiners expect to know the difference between nuclear fusion and nuclear fission. Fission's got double S, fusion's got a single S, so notice I've written down there two S's. And fission is about splitting. It's about the splitting of nuclei. The centre of atoms are split. You need to know that there are certain isotopes that we use in nuclear power. They are uranium-235, plutonium-239, and the 235 and 239 are referring to the atomic masses of these elements. What exactly is fission? I'm going to see an example here. In the nuclear power plant, they will fire a neutron at a very large atom of uranium-235 or plutonium-239. And when it does that, it absorbs it, and then it splits in half into two different halves, and then it releases also three other high-speed neutrons. And those high-speed neutrons then go on to collide with other nuclei, and they split as well. They split up into two halves, and then of course they also give off three neutrons as well. Now that there is known as a chain reaction, and each time one of the atoms splits, it either gives off two or three neutrons. It varies, sometimes two, sometimes three. Gives off a lot of energy in the form of heat and also kinetic energy. In a nuclear bomb, you would allow it to go from 1 to 3 to 9 to 27 to 81, basically each time trebling the number of nuclei split. In a nuclear power plant, that cannot happen because we absorb two out of the three electrons are absorbed each time to stop it from becoming an uncontrolled chain reaction. So here's a diagram of a nuclear power plant, and I'm just going to talk you through the various bits and bobs and how it works. First of all, in green are the fuel rods. That's our uranium-235 or plutonium-239. And what happens there is they fire. By themselves, they're perfectly harmless. You can actually sort of hold them in your hand. But in you may have seen it in The Simpsons, for example, that people are holding these rods. But when you put them together, they give off neutrons and they can set off this chain reaction. Now, when they do that, they give off loads and loads of heat. So the water there collects the heat. The bit that's labelled 2, by the way, those there are known as control rods, and basically they absorb neutrons, so that if you want to shut down the reaction, you drop the control rods, and if you notice, gravity will cause them to fall down by themselves anyway. You drop the control rods, and that will absorb the neutrons and cause the fuel rods to cool down. Fuel rods in a power, there may be 90 or maybe a couple of hundred fuel rods, in fact even more than that, maybe even like 800 fuel rods, I think. You don't need to know the number, there's just lots of them, not just 4 that we have there. And the control rods basically are lowered and they absorb the neutrons to stop the chain reaction. But here you notice the control rods are taken out to a certain point, and the water in there is being boiled and turned into steam, and it goes along pipe number 3 and heads into this bit here, the heat exchanger. Now the water going around the reactor is kept separate from another system that goes to the turbines. So this water, which is under enormously high pressure and at a temperature of in excess of 300 degrees C, well in excess of that, in that heat exchanger, the heat from that steam is changed, causes the water pumped in at the bottom there, which says water from. That's cool water that's come from the turbines. It goes up through this series of pipes, and by the time it gets to the top, it's turned to steam, again at very high pressure. And that steam then goes to the turbine room, where it turns a typical turbine. And you should know about how to create electricity from that point there, in terms of turning a turbine, turning a generator, and so forth. The steam that came in at the top, where it says heat exchanger, of course would have passed its energy and its heat energy onto the other circuit of water and pipes, and so by the time it reaches the bottom it would have cooled down. You can see there the water coming from the turbines, and of course it goes out to the turbines at the top as well. At 7 is basically a pump to keep the whole thing moving around. So you have basically two separate systems of liquids there that don't mix. The other thing I want to point out is the water in the reactor is coolant. It cools the fuel rods down. It's also a moderator. Now a moderator in this case is something that slows down neutrons. It has to slow them down in order to stop them and make sure they can be absorbed by the other nuclei. As one neutron fires from one place to another, if it's going too fast, it can't absorb it before it splits. We've also got I want to show you here that there's a big concrete shell all around the reactor. I remember speaking to someone a long time ago. It was a person at a nuclear power plant who said the concrete shell is so thick that a plane could smash into it and it wouldn't break the reactor core, which is great to hear that. Right, finally, what we have here, these are the key words. You need to know fission. If you notice, I've made the I's really clear because fission is splitting. And make sure you've got double S as well. Remember that splitting has got 2 I's, fission has got 2 I's. You need to know about chain reaction, how one atom can then lead to splitting of another 3 and so forth. You must know uranium-235 and plutonium-239 are the fuel sources in a nuclear power plant. You must know the control rods are used to control the amount of heat in there because they absorb neutrons. The moderator is used to slow down neutrons to make sure they can be absorbed. And every time a nucleus splits, it gives off 2 to 3 neutrons. And finally, the plural of nucleus is nuclei, and that is everything you need to know about nuclear fission and power plants.